Hi, thank you so much for hosting me today. I'm so excited to be here. My name is Sierra O'Brien, and I'm a senior mobile consultant out of Cincinnati, Ohio. And today I'm going to be talking about accessibility in Android, which is such a great topic for all Android developers, from beginners to experts. One reason that I'm really excited about talking about accessibility in Android is because one of Google's missions is to make the world's information universally accessible and useful. And so they have made it really easy to add accessibility and build accessible apps using their Android framework. So I care a lot about making tech more inclusive and more accessible. And there are two parts of this for me. First, I want to make the tech space itself more inclusive and more accessible to more people who want to be involved in building these kind of products. And so I try to be really involved in organizations like Women Who Code and other organizations that are dedicated to building a more inclusive and diverse tech space. Second, I want to be part of teams that build accessible products that are inclusive and accessible to more people. And so today we're going to be talking about ways to build inclusive and accessible products using the tools built into the Android framework. This is going to help people with physical limitations use your apps more easily. But I want to be clear that building accessible, inclusive apps doesn't stop with just the physical limitations. There's lots of other things that we need to consider that we won't be talking about today. I encourage you to think about the content of your application, what kind of language that you're using. Is your app inclusive to all the different genders? Are the images that you're using also diverse and represent your whole audience? So knowing all this and how important it is to me, I think the next thing that we have to talk about is how do we get the business to buy in? I find that building accessibility into your app is also in that same category as unit testing, where we know as developers that it's really important to do, but it's also a question of what business value does it add to the app. So here are some reasons that you can encourage your boss to think about accessibility. First, it opens the door to more users. 1 in 4 people have a disability. And so with 2 billion Android users around the world, as reported in 2017, that means that 50 million Android users have a disability. Second is risk management. And so this means that it's actually something you have to do to mitigate risk in your app, to meet ADA compliance. An important case that was originally brought by a blind man who sued the pizza chain Domino's after he was unable to order food through the website and mobile app despite using screen reader technology. He won that, and this opened the door to all apps and websites required to meet ADA compliance. This is also a really important case because e-commerce is a very mobile-first platform, and that can shut down a huge portion of your sales and money out of your bottom line, because there are folks that will spend more money to buy products off accessible applications. And now we switch to things that I think are really important, and what really helped me be committed to building accessible apps is that it's just better for everyone. A really easy example of this is if we think about hashtags. When we write hashtags without using camel case, and so on the left side we see women in tech, first on the right side we see women in tech. As someone who has no disabilities, seeing the right-hand side is just easier to read because I can pick out the words. It also helps screen readers read words, so it's not just a gobbledygook of letters in a row. There are also a lot of other examples of things that you use every day that are actually built for accessibilities. When you're in a forum, typing in your information on your computer and using tab to switch from box to box instead of clicking into them with your mouse, that's also an accessibility feature. Similarly, if you think about curbs at the airport where there's a dip in the sidewalk, that makes it so much easier to pull your luggage or to push a stroller up onto the sidewalk. That was originally built for accessibility so that folks in wheelchairs could get onto the sidewalk easier. But just a couple of examples of how building accessible products makes your product better for everyone. And finally, it's the right thing to do. One of my favorite quotes is from Kim Creighton, the anti-racist economist, and she says, prioritize the most vulnerable. It's one of her 4 tech principles. And so building an app for the most vulnerable will make it better for everyone. And another quote from someone I really respect, Tatiana Mack says, compassionate action is better than empathy. And so building accessible products is an action that you can take that makes the world and your application just a little bit better for everyone. So now we're going to dive into some of the specifics of what we're going to be talking about. And so the first thing we're going to talk about is the types of disabilities that that users may have when they're interacting with your application and what they might be using to interact with your application. So the first is motor impairments. And so motor impairments could range from using a wheelchair, like we talked about with the curbs, to just having shaky hands. And so users that are experiencing motor impairments may use hardware device, like an accessibility switch, to control your app or use the accessibility menu. Cognitive impairments can range from dyslexia to cerebral palsy, and they might use action blocks to set up routines. Action blocks were added by Google to let you set up a routine to do things that you do over and over and over so you can do them easier and access them quicker. Visual impairments can range from color blindness to full blindness, and so they might use things like increasing the text size of your app, using a Braille keyboard, or using TalkBack to read through your application. Deaf and hard of hearing can range from just some hearing loss to full loss of hearing. And so users experiencing some hardness of hearing might use closed captioning, live transcribe, or live captioning to know what's happening in your app. If you open your accessibility settings inside your settings on your Android phone, you'll find even more options that folks might use on their device to make it easier to interact with their applications. It's also important to note that folks like me who are considered able-bodied might find situations or temporary use of any of these kind of features. For example, I am right-handed and have much better motor capabilities in my right hand. And so when I'm using my phone, most of the time it's in my right hand. But I might fall and break my wrist or break my hand, and then I would have to use my left hand for that temporary amount of time. And so I might find that I also have motor impairments for those few weeks. Similarly, I wear glasses. And so after I go to the eye doctor, my eyes might be dilated and I might have a harder time reading my phone. I also have a really bad habit of staying up really late, much later than my partner. And so I often use closed captioning to watch Netflix so that I don't wake him up. And so again, a running theme throughout this presentation is that by accounting for these kind of disabilities and building software that prioritizes them will make your app better for everyone, whether it's a part of their life, a temporary impediment, or a situational. So, what are the content accessibility guidelines, and why does something about web matter for mobile? So the Web Content Accessibility Guidelines are a set of guidelines meant for improving accessibility. They are produced by the World Wide Web Consortium, and the most recent published version was from 2018. There are 3 tiers inside these guidelines. Tier A is basic accessibility. AA tries to address the biggest and most common barriers for folks with disabilities trying to use the web. And AAA offers significant improvements to accessibility, but often can be quite complex. The most important thing about these guidelines is that they're designed around principles and not specific content and technology. And that means that they can be applied to other frameworks outside of the web. And so we can use these principles and also apply those to mobile to figure out what we should also be doing. Those principles are perceivability, and so things about how your app is viewed, operability, which is considering things like navigation, understandability, and robustness. And so that also means that this presentation, while focused on the things that we can do in Android, can also be applied to other mobile technologies like iOS. In general, we try to target level AA, but it's because it's not always possible to reach the AAA tier. but it doesn't mean that we should stop once we reach AA. We should always keep trying to fix those AAA things, but AA is the minimum. So what kind of things does this mean that we can talk about today? So the things that we're going to talk about that are in that AA tier are touch target size, color contrast, labels, the accessibility APIs provided by Google, and text size. So throughout this presentation, I'll be using an example app that I wrote, and you can find that online if you want to dig deeper into the code. My username on GitHub is Sierra O'Brien, and the repository is examples that's pinned to the top of my profile with a folder inside called www.code accessibility. And it's built out on different branches so that we can start at the beginning and build out. What you'll find throughout this presentation is that there isn't actually a lot of coding that we have to do. And so this is just some really basic examples to get us started. So let's start by looking at the app that we'll be using today to look into some of the features that are available to us. So a quick example of what the app does is going to play on the left side of my screen. So we see it's an app. It takes in a username and a repository name, and then you have the ability to fetch commits from that repository, and it will display it in a list. There's also a refresh button and a clear button that will clear out that username and repository. So on the right, we have a little bit more detail about this application. So at the top, we see that there's a text view and an edit text that will describe the field and allow you to input that information. We have the clear button that will remove the username and repository so you don't have to backspace through it. We have a fetch commit button that pulls the commits for a given repository for a given user. And then we have a recycler view, which is the list element in the Android framework that will display each of those commits in a scrollable list. And in the bottom right, there's a refresh button. On the bottom left, you see the check mark, and this is actually an accessibility feature and not a part of the app, which we'll talk about on a little bit later. So how are we going to test our app for accessibility? There are a lot of tools available for you to get started. The first and most important is manual and user testing. No matter what kind of tools we're using that are automated, they're never going to test in the same way that a user will actually be interacting with your app, specifically a user that needs to use your accessibility features. And so the first thing that we want to do is you yourself use your app. As someone who's maybe not used to using these features, it's important that if you can use it, other people can also probably use it. And then also soliciting feedback from your user base, just like we do with our UX research. We always want to find out where our users are struggling, what makes sense to them, and how we can improve the app for their use cases. And so we can do the same thing with accessibility. However, we don't want to throw an app out into the world and ask for feedback that we haven't addressed some of the most basic features. And so the Android framework and Google have provided a lot of tools that we can use to get started and address some of the easily identifiable concerns. So we have analysis tools like Accessibility Scanner, UI Automator View, and lint tools that can help us start pinpointing those. We're going to talk in detail about how to use the Accessibility Scanner, but what the Accessibility Scanner does is it's going to go through your app and take a picture or a video and label things that are missing from your UI. Similarly, the UI Automator View is inside Android Studio and can help you look at the different levels of your view and help you debug them. Lint are built-in lint checks that can identify and give you warnings where you're missing things. Some examples of this are going to be if you have an image view and are missing a content label. And so these can give you feedback while you're writing your code itself. There are also automated testing tools that you can build into your test suite that will run the accessibility suite. These can be built into UI tests like Espresso and RoboElectric, and we'll look at how to do that a little bit later. So Using Accessibility Scanner. So Accessibility Scanner is an app available on the Play Store that you can download and use on top of any of your apps, but specifically the apps that you're writing. And so if you look for it out on the Play Store, you'll find Accessibility Scanner by Google, and you can install it onto your phone. Once you have this, you'll be able to go into the accessibility section of your application and turn on different features that folks might be using to interact with your app. As you can see, it will show you the apps that you have. So we can see Accessibility Scanner. That's a downloaded app that can help you. And also other things that you might want to use, such as Select to Speak, Talkback, text-to-speech output, font size, display size, and theming. When you want to use your Accessibility Scanner, you can click into that first line item and see the options for Accessibility Scanner. So we want to turn on the Accessibility Scanner. And when this happens, we'll go through a couple different steps that ask you if they're allowed to paint over your image so they can interact with the UI that you'll say yes to and give permissions. And then you'll see your blue check mark show up. And we'll see how to use that in the next slide. So a demo with Accessibility Scanner. So I have already gone through into my accessibility settings, clicked into my Accessibility Scanner and turned it on and given it permission to interact with my application. And so you see in the video preview that I have my little blue check mark. So if we go ahead and play this, we can see that I clicked it and I have options to record or take a snapshot. And so either one will record my app and do it. So in this case, I picked that I was going to take a screenshot. And so now it has labeled the different parts of my application that I might need to reconsider. And so we see a box around my username. And if I click into it, it gives me one suggestion. It says touch target size. Consider making this clickable item larger. The item's height is 45 and the touch target is 48. And if we click into more information, they will give you support about why we need to change this, what design, and how to test it. And so we can do this for each part of my element. And so I can go into the next one, look at the suggestions for my buttons, and keep going so I can go through and fix each one of these individually. So on the next screen, we are going to talk about what this Accessibility Scanner does. So the Accessibility Scanner is a great tool, an important tool, but it is not perfect. It can only check what is actually on your screen. And so this brings us back to remembering that no matter which tools we start with, it's never going to give us a perfect recommendation for how we need to update our application. So here we see 3 screenshots that are mostly identical that bring up different number of suggestions between each one of them. And so this is an example of how the Accessibility Scanner is a good tool, but it's not perfect and depends a lot on what we're actually testing. And so we need to be robust in our testing as well. So in every screenshot, it knows that the target size for both the username and the repository field are too small. We saw that in the demo that it is currently a 48 and the current is a 45 and the recommended is a 48. It also knows in all of them that the target size for the clear button is also too small. And so we have 5 suggestions accounted for on every screenshot that we know what those are. And so what are the 7 on the other 2? So in the first screenshot, I have a button implementation, but I have changed the text color. And so now I know it is no longer AA tier compliant. So we see that fetch commit buttons that has a light purple and a dark purple background. If I did the work to find out what the color contrast ratio is on for this, it's actually only 2.87 to 1, and we know that it needs to be higher. On the second screenshot, the button is disabled, and so it's a light purple text on a gray background. And on the third screenshot, we see that it's still a light purple text, but this time I explicitly set the background color to purple. And so now we see that it is actually labeled. In all screenshots, that color contrast is incorrect, but only when I explicitly set the background color and don't let the operating system automatically change the background color does the accessibility scanner recognize, oh, this is not the right contrast. And so this is something we need to watch out for when we're thinking about our buttons. In all cases, we need to change the color contrast, but only in one case is it recognized. In the second screenshot, we see the scanner has addressed 5 suggestions, but we only see 4 boxes, and that's because the refresh button actually has 2, and so they can have different numbers even though they have a certain number of boxes. And in the final screenshot, we see that in this case, it's a different scenario than the first 2 screenshots. In this case, there are no items lists, so we haven't actually fetched our commits yet. And so it's an empty list. And so in this case, that view is tagged, whereas in the other 2, because it has content, it's not tagged as missing a content label. And so our accessibility scanner is a really great way to get started, but will never be perfect. And it also requires us to be really careful about testing all the different scenarios that could happen on our screen. It's also important to note that Lint can also warn you about those things that the accessibility scanner will also tag. So in this case, you see that Lint does warn you for those edit texts that the missing accessibility label, we need to either provide the view with an Android label for, or we can provide it with an Android hint for this edit text. And so that's also a really great tool to pay attention to while you're actually writing your code so that you don't have to run it and run the accessibility scanner and then find out later. So as we dive in and start fixing these problems, the most important thing about accessibility is consistency. The app needs to behave the way that the accessibility framework expects it to behave and the way that your users expect it to behave. As mobile developers, we have a lot of choices to make where we can make our apps act in totally bizarre ways, but we expect to follow the design principles that almost all Android apps use or all iOS apps, and give those apps the look and feel of an Android or iOS app respectively, because that's what our users expect. And if they don't know how to interact with our app, they're not going to continue to use our app. So there's a lot of things that you can do by defining custom accessibility actions and announcements and controlling the focus of your app. But if you find yourself doing this, you should stop and take a step back and think, why am I writing this app in such a way that I need to do this? The Google developers have provided a lot of APIs that we've already seen some of them to implement consistent accessibility practices throughout your app, even with custom views and customizations. So let's get started and look at some of those options. So in this case, we're going to start with talking about touch targets. And so if you want to follow along in the GitHub repo, you'll need to switch to the branch touch targets. So touch targets. The recommended size for each interactive UI focusable area or touch target size is at least 48 by 48 pixels. However, this does not mean that the UI's visible area must be at least 48 or by 48. It only means that the area that the user can interact with needs to be 48 by 48. This can be achieved by adding padding and height, or using min height and min width to give you an overall interaction area of 48. So this means that your padding on the top plus your height plus your bottom padding needs to be at least 48 to give it the height for 48 by 48, and more specifically, and your start padding plus the total width of your element plus the end padding also needs to be 48 by 48. If you haven't used Android a lot and have never used min height, you might not know what it does. And essentially all that it does is add some extra padding to make sure that you meet that minimum requirement. So on the left-hand side, we have an image where the clear button is set to wrap content for the height. And so the background is tightly wrapped around that text field. And you see that the clear has no extra padding around the word clear. That background is wrapped right around and has a height-wise. So on the right-hand side, I've actually added, we have an image where the minimum height is set to 48. And so now instead that background color has given that extra space around clear to meet that 48 requirement that I set for my minimum height. So let's jump into where we have seen this UI element from our screen accessibility scan. So we had 4 different elements that each had flags for touch target. We had both of our edit text, we had our clear button, and we also had our image view in the corner. So I think it's important to note that when I was using my edit text, they were actually set right out of the box from Android with no special customizations. And so it's important to note that even the edit text from the Android framework won't always meet these UI touch target requirements. And so on my edit text and my text view for my clear button, I can add that minimum height of 48 to make it meet that requirement. You might wonder why I don't want to set my layout height to be 48 and instead set the minimum height to 48 and leave layout height as wrap content. And in this case, it's because when we think about text views and internationalization, and later when we talk about the text size that can also be updated in the app, we don't want to require our text view or our edit text to be a specific height so that it can wrap that content around instead of cutting it off when it doesn't fit inside. And so this allows for more flexibility, which also allows for other accessibility features to work as expected. On our image view, we had our layout height and layout width set to 48 by, we had it set originally to 40 by 40, and now we want to update it so that it's instead 48 by 48. In this case, we want to meet our designers. We want to meet our designer's expectations, and he says, "I want this image view to be 40 by 40." And so this is coming back to the fact that just because it has to be an interactive area of 48 by 48, it does not mean that the image itself has to be 48 by 48. So in this case, we change the layout height and width to 48 by 48 and add padding on all sides to contain it back, the image itself, back to that original size. And so now when we rerun our accessibility scan, we find that we only have one suggestion on our screen, although we've already talked about that we know we have some others that weren't caught. And so we see the suggestions for the edit text and the clear button have all gone away because they now meet that 48 by 48 requirement. And the only thing that we have left is that there's a missing attribute on our image and the other things that we've already talked about. So now let's talk a little bit about color contrast. AA compliance requires at least a 4.5 to 1 color contrast ratio for regular text and 3 to 1 for large text. So what does this mean? It means that the color on the actual text and the background color have to meet these kind of ratios. And so we have a couple of different examples here. So on our right-hand side, we see that fetch commits button that we talked about earlier, and it's only 2.87 to 1 because we have that light purple color on top of that dark purple color. And so the contrast between the two of those is not high enough. If we change that text to white so that we have white text on dark purple background, then we reach a 7.62 to 1 ratio. And so this meets AA compliance. For reference, these slides are a 5.88 to 1 color contrast ratio for the gray color, for the light gray color on the darker gray background. So how do I check to make sure my colors are within that contrast? There are lots of tools online that can compare colors for you and help you pick colors. And this also brings up, how do I meet my requirements of sticking to my theming and matching my colors and also meeting these requirements? And Google has provided the material color palettes that can help you find various shades of your same theming so you can meet these different requirements. So in my theme that is a purple and white theme, I could find a much lighter color purple from the material design color palettes so that I could still have that purple text on a dark purple background if I find the right two purples within my palette that meet that requirement. So now we're going to switch and talk about labels and hints. The basics of adding labels is so that each UI element in your app includes a description that describes the element's purpose. We do this in Android using a content description, though we automatically get some for free out of the box. For example, we do not need to provide a description for a text view because the Android accessibility framework will automatically announce the text as its description. Some best practices to keep in mind when you're thinking about how to make your labels is, number one, use the right UI element. So if you need an action like a button use the button element. Don't include the UI element itself in the description. So if you have a button, you don't need to add the word button to the end of the description because, again, the Android accessibility framework will automatically add that for you. Descriptions should be unique so that they know where they are in your app screen. If you have several things labeled the exact same way, they won't know if they're circling through the screen or somewhere different on the screen. And you can skip over decorative effects like dividers because they don't add any relevant information to how your app is functioning. And the best way to write UI labels and hints is to use localized, concise, and descriptive wording. So it tells you what it's doing quickly and in the correct language. So the first step for this is using the right UI element. So we started our app with a clear button, a fetch button, and a refresh button. And what actually happens is that only one of those started as an actual button. So our fetch commits button is an actual button UI element, whereas our clear is actually just a text view. We saw that a little bit earlier when we were talking about adding the correct padding. And the refresh button is just an image view that's sized correctly, and an on-click listener is added. So when we switch out our text view for a clear to a actual text button, it gives us a lot of other things for free, so that it makes it easier for theming as well. It will change your background automatically to your accent color. It adds elevation so that it looks clickable. It correctly adds the padding to make it meet that touch target size requirement, and it automatically adds capitalization to make it look like a button. And so on the right-hand side, we've switched out our clear and our image view to be buttons. With our edit text, we also want to add hints to the edit text. So the username and edit box were both edit text so that we can add in your username and your repository name. When we clear those out and rerun our accessibility scanner, we would find out that the accessibility scanner would flag both of those for not having a hint included. When we ran it the first time, we had my personal username and repository name already inside of it, and so it had a text to read and describe as the content label. And so there's two different ways to associate a hint with an edit text, and we already saw those when we talked about the linting rules. So we can first add a label for our text view. So in our example, we had username and then the text view. And so by adding this Android attribute, Android label for right here, then it pairs those two elements together and knows to describe them as one element. And so the text view with the string username, we add the label for username input, and it knows that it's now associated with the edit text with the ID username input. Or we can add a hint, which is also a hint to the edit text itself, which is an example of valid input that's available to the screen reader. And so in this case, on our edit text element itself, we had Android hint right here, which is a different Android attribute. And so we can add the hint string repository and associate that with the edit text itself. Either one of these is a valid way to associate a content label with the edit text, but it's important to know that you can only do one. Android itself will yell at you for it, And in my example on the left-hand side, both the hint and the text view itself would have the exact same content label. And so Android would also note that, is that I use string repository to describe my text view, and I added the hint string repository in my edit text. And so now those have the same label, and so they don't meet our requirement for concise, unique, and localized hints. And so I personally prefer the right-hand side, or personally prefer the left-hand side of associating my text view because I have that name already with the edit text itself. And another important thing is how to group these labels in a way that makes sense. We're calling back to our Web Consortium guiding principles. One of those includes understandability. And so we want to make sure that we group our labels in a way that makes sense. So if we recall our example app, we had that recycler view that has each one of those elements from each commit. And so out of the box, the talkback from Android will read each recycler view as one continuous label and include the position of the list. And so for our example, this probably works because there's nothing that needs to be read separately. Each commit has a message, has a date, and has an author. And so all of those make sense to be read at one time. But there are examples of times when we might not want that to happen. For example, if there might be a button on your list, or if we think about something like a quiz app where it might have radio buttons that you can select the correct answer, and it has a list of those. You want to go through each element inside that recycler view and read those individually so that the user can interact with each one separately. And so to do that, I can add the screen reader focusable to one of the UI elements and it'll be read separately. And so on the left-hand side, I have my constraint layout that I use to describe my, my commit items for my recycler view. And so in this case, I added on my text view for my commit message, screen reader focusable true. And so now when it reads through it, it will first read each item and read everything that is not screen reader focusable. So in this case, it would read the author name and the date. And then I could separately scroll again and it would read my commit message separately. And so this is something that we can do when we want to interact individually with things inside the recycler view. If we want to consider this outside of recycler view and consider other examples of grouping labels, so in number 2, if this were not a recycler view, I can use view attributes to make it read as a natural group. This can make finding information on your screen more efficient. And this is important because you have to recall that someone has to sit and use your app by listening to each of these messages. And so we want to make the information reachable and efficient so they can use it very naturally. And so in this case, I added that screen reader focusable true to the constraint layout itself. And for each text view inside, I added focusable false. So now if it ran across this constraint layout UI element somewhere on my screen, it will read the whole thing as one, similar to how we read the recycler view, each as one. And so if there's no reason to interact with each element individually, it makes sense to read it all as one single element so they don't have to scroll through each one separately. Finally, sometimes you might want to read the container itself, but also read the contents of that container. An example of this might be an event website that has a calendar on it. And so you can think about, you might want to read the day container that just says events for the day for March 8th, 2021. But then you also want to let your users scroll through each individual thing if they're interested in that day's events. But if I'm not interested in the events of that specific day, I can just scroll to the next item. And so in this case, we can add that screen reader focusable true to the constraint layouts and add an ID. So in this case, I added the ID container A and container B, but I don't want to add onto that add that focusable false that we saw in the previous example. So this will let us read the container itself and then also read the individual items inside that container. Another really exciting part of the Android accessibility framework is TTS span. A TTS span is a special type of span that can pass in metadata to give contextual information about that string. This information can help text-to-speech, so TTS, correctly pronounce a text element name. One example of this is the type digit that I think is really exciting. So if I have an example of 1, 2, 3, 4, 5, 6, 7, 8, 9, without TTS span, this will be read as 123,456,789. Using TTS span and the type digit, I can now read this number as 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this is really great for things like addresses, where I don't want my address in Ohio to be read as Ohio 45,044. And so instead I want my zip code to be read as 45044. And so this has a lot of different types that can also be used that can help with dates, digits that we just saw, phone numbers, electronic amounts, and other things that are really common in applications. Finally, Google has added a lot of accessibility APIs to help with custom views and how they can interact with them. We recall talking about how important consistency is to building accessible Android apps and how we can go in and override the accessibility framework. These accessibility APIs can help a lot with common things that we see in Android applications and custom views. So for example, swipe to delete is a really common way to delete things in Android. You see it in a lot of emails, and you see that pattern throughout other applications with lists of things that you can get rid of. We talked about that the accessibility scanner can only see things on the screen. And so the swipe to delete doesn't exist on that screen. And so Google provided an accessibility action API where you can add an accessibility action to your cell that can allow the accessibility scanner to read this. And so by using this, in this example, it's actually on a mail cell. You pass in your view, you add the string for it to read, and then add the action that it will perform. So in this case, we're adding it to our mail cell. The string that it will read will be removed, and in that case, it will call mailcell.delete. Another really important accessibility API that they added was to help read spans with links. It's always been able to read URL links, but there are other types of links that we can include in those spans. And so by using the enable accessible clickable span support and passing in our view, it will automatically read those links inside that span. And finally, there's sometimes when you need to use a custom view to meet your design requirements. And so we can't always use the views that Google provides that already have those accessibility APIs built in. And so, for example, if you want to build a really specific alert view that tells your user that something has gone wrong, but you can't use the alert dialog already built into Android, you can use a set accessibility pane title to the custom view that you've already built so that it knows that it should behave like an alert view, like an alert dialog. And so in this case, we pass in our alert view and we pass in a string for what to associate with it. And so these are really exciting things that have been recently added to the accessibility framework that we can use to handle some of these cases. We can also think about the different ways that people might want to display your application. So one thing that we talked about is large text size. If we remember how this can help you build a better app, if your app can handle a larger text size, is built to handle a larger text size, it will also be built to handle a regular text size and a smaller screen. And so by building an app that allows that text to shrink or grow, it will also allow your app to scroll and change the padding as necessary on different kind of phones. Also, when we think about dark mode, as developers, we see it a lot with all of our different IDEs and setting our IDEs to dark mode to develop. But dark mode is actually originally an accessibility tool. And so by building out a dark mode for your accessibility, folks with accessibility needs, you're also building out a dark mode for any of your users who prefer using dark mode over a light mode. And so again, by building an accessible app, we're building a better app for everyone. People who want to use dark mode, people on small screens, making buttons easier to click. It's really important for everyone to be able to use our app. So we can also, there's also built-in accessibility checks for our espresso test. We know that testing our mobile frameworks is really important. And so this offers a way to run the accessibility checks every time that you run your UI test. So what is accessibility checks going to check for? It's going to check for really similar things to what our accessibility scanner does, but can be automated to be a part of your build process. So we'll check for missing and incorrect labels, small touch targets, low contrast, and other implementation-specific issues. And it tries to flag things that won't send the expected values to the accessibility framework. As you interact with different views in your UI test, these accessibility checks will run on each of those before proceeding. So if you're interacting with a button, it will check the button and return all the accessibility issues associated with that button, like the things that we saw earlier with touch size and contrast. To use this in Espresso, which is a pretty common test framework, all you have to do is add accessibilitychecks.enable in your testing. Inside of RoboElectric, the other UI test framework, you can add accessibility checks to do this. So we talked a lot about a lot of things that we can do right inside our app, but there's other best practices that we can also consider. So we talked a little bit about custom views, but in some custom views, you will have to override and add your own accessibility endpoint functionality. And we haven't talked about other media. So like videos, it's really important to make sure that when you have videos, there's options to skip it. There's options to go back and rewatch it. And there's options to read through it instead of listening through it. So now that we've talked about all these things, where do we go from here? So number one, the web accessibility guidelines are set to be updated this year, which is really exciting. What does that mean for mobile? As we become a more mobile-first world, we expect that the accessibility guidelines will include more information about mobile. The first draft was actually published in late January and is available online. A lot of this presentation was done in XML, and now Android developers around the world are moving towards Jetpack Compose, which is a really exciting declarative UI that went into beta on February 24th. So what does this mean for accessibility? To be honest, I don't know yet, but I'm really excited to find out. Having played around with Jetpack Compose, things that I do know are that content descriptions are required to be passed in to create an image object. And I know that the team at Google has already promised that Jetpack Compose will continue to work towards accessibility before they release their official stable Jetpack Compose release. So if you have any questions or want to reach out and talk more about mobile accessibility, you can find me on Twitter at _CROBryan, or you can find all my contact information at CROBryan.com. Thank you so much for having me, and I look forward to being here in the future.